Hello everyone, I'm Sagar Dhotare. In previous lectures, we have discussed about the design of deep groove ball bearing, angular contact bearing, and a deep groove ball bearing with cyclic load. Okay. Uh, in previous three example, we doesn't consider about the temperature gradient. Okay, or the effect of temperature. Here we are going to design a spherical roller bearing with this temperature effect. Okay, let's see how that temperature effect get affected over the bearing design. So let's see the problem. Select a suitable spherical roller bearing to be subjected to a radial load at 4 kilonewton and axial load of 1.2 kilonewton running at 900 rpm. The bearing is expected to operate at 125 degrees centigrade for a life of 6,000 hours with a reliability of 93%. You can say probability of survival is 93%. Okay, so we need to solve this problem by considering the temperature gradient and without temperature gradient. I will explain with and without. Okay, so first of all, just note it down. The spherical roller bearing, uh, what are the basic input? The type of bearing is spherical roller bearing, radial load, that is FR 4000 Newton, FA 1200 100 Newton, then speed N 900 rpm, life in hour, expected life in hour, LH is equal to 6000 hours, then probability P is equal to 0.93, and the temperature, that is a 125 degrees centigrade. Okay, now first step, we need to calculate a rating life for 90% probability of survival. Okay, because whenever for calculation purpose we are using this life for calculating the value of C. Okay, so for that purpose we first of all converting the given life into the life of 90% probability of survival. Okay, by using equation LH divided by LH10 is equal to natural log of 1 by P divided by natural log of 1 by P10 raised to 1 by P. So here the value of P is 1.17, referring page number 4.2, because it is not a deep groove ball bearing. Okay, and considering the mating life is 5 times of L10. So expected life, that is LH, is equal to 6000, and the life for 90% probability of survival, that is LH10. Putting all the values of probabilities and the value of B, what we get, the life for 90% probability in hours is equal to 8251.66 hours. Okay, so as we know that as the probability get increases, the rating life is get decreases. Okay, so here the expected life was 6000, but but when the probability get reduced, the life get increased. Okay, and this L10 we have converted into million revolution by using equation L10 is equal to LH10 into 60 into N divided by 10 raised to 6. Okay, so LH10 is equal to 445.58 million revolutions. So for 90% probability or reliability of survival, the value of the bearing is, or the bearing should run up to 445.58 million revolutions. okay, that we have found. Now we need to calculate a equivalent load. So first of all, we need to calculate FA upon FR ratio. Okay, so we don't have the value of bearing. We have to assume the values of FA upon FR. So first, no, sorry, we need to calculate the value of E, uh, but we don't have a designation of bearing. That's why we are considering further. First of all, calculate the FA upon FR ratio, that is 1.2 kilonewton divided by 4 kilonewton is 0.3. Now we need to refer PhD page number 4.4. From PhD page number 4.4, what we seen, I will share you. Okay, from PhD page number 4.4, it is seen that for spherical roller bearing, I will show you the segment. For spherical roller bearing, which is given with the designation of 22205C to 22207C series, the value of E is nearer to 0.32. Okay, and our ratio FA upon FR ratio, what we get are 0.3. So we have considered that the FA upon FR ratio near about equal, or you can say if you're referring the value of FA upon FR ratio, the first column which is getting selected. Okay, so we have selected this column, okay, as per the FA upon FR ratio. So the value of X is 0.67 and the value of Y is equal to 3.1. Okay, I hope everybody get the point. पहले हमने क्या किया कि FA upon FR ratio calculate किया. Then we have to select a spherical roller bearing column, rows. उसमें हमने E के वैल्यू के साथ FA upon FR ratio की वैल्यू कंपेयर की, तो उसमें ऐसे दिखा कि FA upon FR की वैल्यू जो है 0.3 है और मैक्सिमम वैल्यू जो है E की इन द सेगमेंट ऑफ स्पेरिकल रोलर बेरिंग वो 0.32 है. ओके, सो हमने वो रो रेफर की जिसमें ये वैल्यू हमें पता चली x is equal to 0.67 and y is equal to 3.1. Okay, so go to the problem. So by selecting those values, we have considered the service factor for given condition is 1.2. Similarly, referring the PhD page number 4.2. To calculate the equivalent load, equation is P is equal to X VFR plus Y FA bracket outside the bracket into S. Okay, so we have already know that the about the bearing rotation, the inner race is always rotating normally, and in this application also the inner race is rotating, so that's why the value of V is equal to 1. Putting all the values of X, V, FA, FR, Y and S into the equation, what we get, the value of P, that is the equivalent load, P is equal to 7680 Newton. Okay, now we need to calculate the value of C. that is a dynamic capacity. So equation for dynamic capacity is equal to L by L10 raised to 1 upon K into P. Okay, now we have already getting the values related to million revolution. So now here we have considered that the L is the required life and L10 is 10 raised to 6 with referring PhD page number 4.2. So putting that values over there, and as the bearing is a roller type, the value of K is 10 by 3, the P is equal to 7680. Now put all the values into the equation. What we get? We get C is equal to 47,849.6 Newton, that is 4784.96 kgf. Okay, now when we going to select a suitable bearing, in this condition we haven't considered a temperature effect. Okay, uh, without considering the temperature effect, the value of C what we get is 4784.96 kgf. Okay, and when we consider the temperature effect, the reduction in dynamic capacity is done by 5%. The reduction in dynamic capacity is get 5%. This you have to given in PhD page number 4.2. I will show you. Okay, so here they have provided the various range of uh, reduction in load carrying capacity based on the temperature value. Okay, so based on the temperature value, the decrease in capacity has shown. For 125 degree it is 5% and so on. So we have considered this one. Now we are considering this one into our equation. What we get, we have increased the 5% capacity. Okay, because it reduces the value. If it is reducing the value, while selecting we need to add that deficiency, so that whenever we are using the appropriate type of bearing, it will be sustain that deficiency very easily. Okay, so that's why I have increased the total value of calculated dynamic capacity by 5%. Okay, and new value of dynamic capacity which I get is 5024.208 kgf. Okay, and the selected bearing from PhD page number, or you can say the new value which is calculated for value of C, that is a dynamic capacity. Now how to choose the bearing from catalog? Okay, let's see. Referring PhD page number 4.32, just we will check how we can select that bearing. Referring PhD page number 4.32. Okay, so here the spherical roller bearing series is provided, series of 222C and 222CK. Okay, so from that we need to select. So for first preference is the dynamic capacity. So based on the dynamic capacity we always choose the bearing, and the calculated dynamic capacity by considering the temperature effect is 5024.208 kgf. Okay, so here the nearest value or more from the given value is 5200. Okay, so this is the value of C which we have selected. So what is the designation of bearing now? So the designation of bearing is 22207C with the diameter of 35, bore diameter that is 35, then outer race diameter is 72, width 23, okay, and having a static capacity of 4050 with maximum permissible speed of 6000 rpm. Okay, so in this way we need to select a suitable bearing. Okay, so in this problem we have discussed about the selection and design of spherical roller type bearing with temperature gradient. Okay, now we will discuss one more problem which is subjected with the shock load as well as the temperature gradient. Okay, okay, so the escape bearing of 6312 is subjected to following cyclic load. Okay, so they have provided different phases with the radial axial load, then speed of each stage and the time of engagement. So here there are three phases which we have elaborated. First one having radial load of 3 kilonewton, second and axial is 1.5 kilonewton with the speed of 300 rpm and it is engaged for 12 seconds. Second stage, the radial load is 5 kilonewton, axial load is 2 kilonewton and the speed is 280 rpm and it was engaged for 21 seconds. And last one, the third phase where the radial load is 8 kilonewton, axial load is 3 kilonewton with the speed of 250 rpm and the time of engagement is 27. So the total time is 60, that is a 1 minute. Okay, so the out of 1 minute this cycle time has been recorded. The load are with the light shock and operating temperature is 140 degrees centigrade. If the outer race is rotating, determine the expected life of bearing in hours with the probability of survival of 92%. Okay, as we know that here this cyclic load as well as the temperature effect is given in this problem. Okay, so let's check how we can solve this problem. Just first of all note down the inputs. The type of bearing is escape 6312. It means it is a deep groove ball bearing with heavy load carrying condition. Diameter last two digit 12 multiplied by 5, so 60 mm. Then probability, required probability is 92%. Static capacity is by referring PhD page number 4.14 we have find out the static capacity. Just let's check. Okay, so PhD page number 4.14, bearing number 6312, we check it. Six three one two. Okay, so the diameter is given 60 mm. Then static capacity is 4800 kgf and dynamic capacity is 6400 kgf. Okay, now we just note down those values, because these values are required for further calculation, as they have provided that the in the equation that light shock and operating temperature is given. So we have considering rotating machine with no impact, and the range of that is 1.1 to 1.5, referring PhD page number 4.2. The service factor, or you can say load factor, is S is equal to 1.3. Okay, and here in this condition they have mentioned that the outer race is rotating. Okay, as the outer race is rotating, the value of V is get changed. Okay, so for outer race rotates condition, the V is equal to 1.2. Now we need to calculate the radial as well as thrust factor for each stage and each phase, or you can say each phase. Referring PhD page number 4, we need to first of all calculate the value of FA upon CO ratio and FA upon FR ratio for first phase. FA upon CO ratio, that is 1.5 divided by 48 is equal to 0.031. Okay, all values are in Newton. And FA upon FR ratio, which we get is 0.5. As we compare, as we know that the range of E lies between 0.22 to 0.44 for deep groove ball bearing. The ratio of FA upon FR is far greater. That's why we can directly pick the value of X is equal to 0.56 and Y is equal to 2. Which one is a maximum? For second phase, we have calculated with the same method, calculating the FA upon CO ratio and FA upon FR ratio for stage number 2. The FA upon CO ratio for stage number 2 is 0.041 and FA upon FR ratio is 0.4. The value of E, which is lies in between 0.22 and 0.41 or 44, that is 0.4. Okay, so it's in that the FA upon FR ratio again greater than that of 0. Greater than that of E. Let's see in PhD, so you can understand very well. Okay, so here is the deep groove ball bearing, and the given value of FA upon CO ratio is 0.41. So we have selected this. We have selected this column. So in this column, the value of E is 0.24. Okay, so value of E is 0.24, but we have FA upon FR ratio is 0.4. It means that the FA upon FR ratio is greater than that of value of E. So that's why we have selected this column. Now the value of X is equal to 0.56 and the value of Y is 0.8. Okay, just note it down. Now similarly, we need to calculate for third phase. In the third phase, the FA upon CO ratio is 0.062 and FA upon FR ratio is 0.375. As the FA upon CO ratio is 0.062, okay, which is lies above than the 0.04 and lesser than the 0.07. So that's why we have considered this column. Okay, so 0.06 we have considered, and we have put in then we have seen that the value of E, the value of E is 0.27 when it compared with the FA upon FR ratio. as the FA upon FR ratio is 0.375, the value is greater than that of E. Okay, so we have to select this column. Okay, now based on this column, what values we get? For X value it is 0.56, and for Y value we can directly find out that is a 1.6. Okay, just note down these values. Now similarly, we have just completed to calculation of radial and axial factors. Similarly, we need to calculate the equivalent load for each phase. Okay, so phase number 1, phase number 2, and phase number 3. What we get for phase number 1, we get value of P is 6.5 kilonewton. For phase number 2, 9.048 kilonewton, and phase number 3, the value get is 13.228 kilonewton. Okay, as phase gate changes, the equivalent load get increased as per the given problem. Now for similar condition, we need to calculate the number of revolutions or the life rating for each phase. Okay, so in this condition, the time is given. Okay, the time, what time is given? The total time, which if we adding T1, T2, T3, what we get? 12 plus 21 plus 27 is equal to 60. Okay, so out of 60, the 12 second, that is a fraction of cycle which is deployed for phase number 1. Okay, so we consider only that number of revolution for that phase. Okay, so equation get modified to while calculating the life rating in a revolution, that n1 is equal to fraction of cycle into LH10 into 60 into n1. Okay, here LH10 we don't have value about how many number of hours the system will work or bearing will work. Okay, we don't have an idea, so that's why, and they haven't provided any information related to uh, expected life. Okay, we need to calculate that life first for 90% probability of survival, that is a LHT. Here small n1 is the speed for phase number 1. Okay, so fraction cycle is 12 by 60, that is a 20% of total cycle. So 0.2 multiplied by LH10 into 60 into 300 divided by 10 raised to 6. So the value of n1, or you can say the number of revolution rating life in the form of revolution for phase number 1 is 3.6 into 10 raised to 3 minus 3 LH10. We have calculated all the values of n in the form of LH10. Okay, so similarly for phase number 2, the fraction of cycle is 21 divided by 60, that is a 35% of total cycle, that we calculated value is n2 is equal to 5.88 into 10 raised to minus 3 LH10. Okay, and for last one, that is a phase number 3, the fraction cycle is 45% of total cycle. Now using similar equation, putting all the values, and we get n3 is equal to 6.75 into 10 raised to minus 3 LH10. Okay, now for each phase we get a proper value of equivalent load as well as the speed. Okay, now we need to calculate a equivalent dynamic load, or you can say a cubic mean load. Okay, you can refer PSG page number 4.2. We'll see. So PSG page number 4.2, they have provided the equation over here the cubic mean load. Okay, so the cubic mean load we can calculate based on the revolution variation or time variation. You can put both way. Okay, but I am referring for revolution way because we don't have an idea about how many revolutions we have. Okay, so that's why I haven't chosen the time variation. Okay, now here in this equation F1 is nothing but a equivalent load for phase 1 and F2 F3 are equivalent load for phase 3 2 and 3. Okay, so similarly N1 that is a life in a revolution for phase 1, N2 for phase 2 and N3 for phase 3. Okay, we have to use same equation for calculation. Okay, so we have written over in the problem that equation in the form of P. Okay, now putting all the values and what we get equivalent load because numerator and denominator having the value of having same factor, that is a LH10 which is eliminated directly. So we get direct value of cubic mean load or mean equivalent dynamic load, that is a P is equal to 10.891 kilonewton. Now next step, we need to calculate a actual rating life. Okay, so equation we know that C is equal to L by L10 raised to 1 by K into P, where L is the required life and L10 is a 1 million revolution. As per when we consider the million revolutions are 90% probability of survival. This equation we can use and these values are we are using for 90% प्रोबेबिलिटी ऑफ सर्वाइवल. ठीक है, हम पहले वही निकालेंगे, उसके बाद हम लोग 92 के लिए कैलकुलेशन करेंगे. One more factor which we need to consider, that is a temperature variation or effect of temperature. So in PhD page number 2 at the bottom they have provided a table where the temperature decreases there and the percent capacity decreases is provided. For 125 degree the 5% capacity get reduced. For 150 it is 10%, but our value is 140 degree. Through the interpolation method we have calculated that the total value get reduced by 3%. Okay, so whatever the dynamic value we have calculated, it is decreased by 3%. In previous problem we have added that value so that we can choose a particular bearing, but in this equation or in this problem they have mentioned the proper bearing type, they have mentioned the value of C. Now we need to reduce that value, so that's why we can get a actual life of that bearing. Okay, so अगर हम लोगों ने 100% लिया तो हमें जो वैल्यू मिलने वाला है कैलकुलेटेड वैल्यू वो ज्यादा मिलेगा. अगर इस प्रॉब्लम में हमने ये माइनस क्यों किया है या फिर रिड्यूस क्यों किया है, क्योंकि प्रीवियस प्रॉब्लम में हमें बेरिंग का डेजिग्नेशन पता नहीं था और वो हमें निकालना था, तो उसके लिए वो जो ज्यादा डायनामिक कैपेसिटी वाला बेरिंग है इट कैन सस्टेन द कैलकुलेटेड वैल्यू. ठीक है, तो उसके लिए हमने उसको ऐड किया था और इंक्रीज किया था, बट इन दिस केस वी नीड टू डिक्रीज, क्योंकि अगर हमने इंक्रीज किया तो क्या हो जाएगा, सी का वैल्यू बढ़ जाएगा. तो सी का वैल्यू बढ़ने से जो हमारा रिक्वायर्ड रेटिंग लाइफ है और जो मिलियन रिवॉल्यूशंस हमें मिलने वाले हैं वो ऑटोमेटिकली गेट इंक्रीज्ड and it will give a wrong calculated value. Okay, so that's why we have decreases the value of C here. If they don't provided the bearing number, again we will अगर उन्होंने bearing का नंबर नहीं दिया होता तो हम लोग इसको इंक्रीज करते. प्लीज डोंट कंफ्यूज in this step. Okay, I hope that I have cleared this why I have added and why I have reduced. Okay, so new value क्या मिला हमें 62,080 न्यूटन, that is 6,208 kgf. Now the rating life based on the phase number 1, 2 and 3, we have calculated L is equal to 16.23 LH10 into 10 raised to minus 3 million revolution. ये एक इक्वेशन हो गया. And using C is equal to L upon L10 raised to 1 upon K into P, इस इक्वेशन से हम लोग दूसरी वैल्यू फाइंड आउट करेंगे. Okay, so that equation, how we can find? Putting the value of L in that equation, MR get cancelled, you can directly find out the value of bearing in hours. Okay, for 90% probability of survival. ठीक है, तो वो वैल्यू कितना मिला हमें? आफ्टर द कैलकुलेशन व्हाट वी गेट 11,411.25 hours. ये हो गया 90% probability of survival के लिए. Now we need to calculate the actual life for 92% probability of survival. सॉरी, जो हमने LH10 निकाला वो 90% के लिए है, अभी हमें 92% के लिए कैलकुलेशन करना है. सो LH92 डिवाइडेड बाय L10 और L90 you can say is equal to natural log of 1 upon P92 divided by natural log of 1 upon P90 raised to 1 by B. As it is DGBB, the value of B is 1.34. Putting all the values, what we get? The life of bearing for 92% probability of survival is 9,583.11 hours. Okay, so in this problem we have discussed to calculate the value for different phases, that is equivalent load calculation for different phases. Then how the temperature gradient, or you can say how the temperature will affect the capacity of the bearing that we have seen. Then we have calculated the life in million revolution with respect to LH10. Then we have calculated the life of bearing for 90% probability of survival, and then we have calculated the life of bearing for 92%. ठीक है, पहले हमने 90 के लिए क्या निकाला, फिर हमने 92 के लिए कैलकुलेट किया. ठीक है, so I hope you have understood this problem. Okay, if still you have any doubt, you can message me. Okay, so and I request all of you to subscribe my channel, so whenever I added a new videos, you can directly get a notification. Please click on bell icon, so directly you can get a notification to your email. So thank you very much for joining me.